Awesome. Welcome DS9. So today we're going to do more with pandas, right? You notice a theme here, right? We do a lot of pandas Monday, Tuesday, Wednesday. Tomorrow we're going to look at some plotting libraries for making graphs and trying to learn how to get fine-grained control over how our graphs look. Up till now we've been doing kind of some quick graphs with using pandas as well. But the library we're going to learn tomorrow, we're gonna dig into matplotlib. Is actually what pandas is using under the hood. Pandas is generating kind of these quick matplotlib graphs for us. We're going to learn how to get more fine-grained control over those tomorrow. But before then, we have at least one more day of pandas. Now we're going to use pandas basically every single day throughout the rest of the course, right? So we're gonna get really good at it as we go along. But today's lesson is really focused on two things. How can we take two data sets and put them together in one data set, either just kind of concatenating, just adding them by rows or columns, or merging data sets where we're going to have two unique identifiers for specific rows. Maybe like we're gonna look at some products from an e-commerce store, right? We're gonna see product IDs in this table and product IDs in this table, and use that to match up information and pull those two data frames together, kind of zip them together by product IDs, right? So those are two different operations that we're going to talk about today, both concatenating and then kind of merging data frames. And we're also going to talk about reshaping our data. That means what determines the column identifiers and what determines the row identifiers, right? There's two common data formats. One's called wide data format, and it's called long data format, right? And being able to translate our data in between these two common formats is really important. Particularly the long format, also known as tidy data format, works really well for graphing and plotting libraries, right? So if we can control our data and get it into that shape, then we'll be ready to start making some graphs with it, which will help us tomorrow and beyond, right? So let's dig in. I'm not going to send out a Slido link today. We'll just use Slack. So, but what you do need to know is I've added content for modules 3 and 4 to the Lambda School version of the repository. So you're going to need to pull these in. I'm going to need to pull them in as well. So I'm going to demonstrate that briefly one more time for you, but I'm going to do it pretty fast. So I'm going to my fork, right? And I see that I am one commit behind, right? So there's things in Lambda School that I don't have. So I'm going to compare these branches. All right. This shows me the changes that I've made, but that are in Lambda School. So I need the opposite of that. I need to switch these two and put my repository on the left. If this collapses, again, hit compare across forks, it'll pop back up. And I need Lambda School on the right, and you'll see adds content for modules 3 and 4. That's good. That's what I want to add to my fork. I'll create the pull request. Basically, just click the green buttons after that. Checking for merge functionality. These should merge cleanly because you don't have these folders or this content in yet, so you shouldn't have any merge conflicts. And at that point, I think we're good, right? So if I come back and I look at my fork here, I see that I have all 4 modules. All right. You all need to do that before you can work on the assignments today. Maybe you're even doing it right now. One thing I will point out is that even though the module 4 content is here, I might still make some changes to the lecture and assignment content before tomorrow. What that means is, if you're a person who likes to work ahead, in the future, you'll start the week with all 4 modules in the repository. This week was a little bit different in that we kind of added them as we went along. If you're a person who likes to look ahead to maybe what we're doing tomorrow or even next week, and you want to do something in the notebooks, what I would suggest is, if you're working ahead of us, do not save your changes back to GitHub until the day that we're working on that content, right? If you save your changes back to GitHub and then I make a change to that lecture notebook, then there's going to be changes coming to that same file from both branches, from both your fork and the Lambda School version, and those are going to cause merge conflicts. They're not going to get along. Now, merge conflicts are a pain with IPython notebooks. They're a pain with any file, honestly. So just be careful about that. Over time, we'll get better at using GitHub. And we won't, over time, we won't even be using, you'll notice we're doing everything here from the website, right? We're doing everything kind of from the GUI, the graphical user interface. Over time, we'll start to use kind of the command line, which is what I used to make the changes this morning, right? For using Git from the terminal. And we will keep on upgrading kind of our tooling as we go along. We won't use Google Colab forever. We'll start to use local Jupyter notebooks in a few weeks, but we just didn't want to overload you with all that tooling stuff at the beginning. I think it's challenging enough to wrap your head around the assignment submission process and for pulling new content to update your notebook in a given week. So we're going to kind of progressively add to the tools that we're using and get closer and closer to industry standards. Google Colab is really good. It's a really good teaching tool, but I don't think it's the industry standard. And so we do want to get to the set of tools that comprises the industry standard in a little bit. And some of you will probably, even once we introduce local Jupyter notebooks, you'll still want to use Google Colab, and that's totally fine. They're compatible. So let's see. Okay. We're back. So now that I have this in my fork, I can get it open in Google Colab. I'm going to use the Chrome extension here. And I'm only going to look at the lecture notebook right now. Don't have to wait for the render of the notebook to load in order to be able to open it. And we're good to go. I'm going to save a copy of this to Drive so that I can then share it with you, because the GitHub version doesn't have very normal sharing settings. And we're going to turn this into the DS9 version. And oh, an internal error has occurred. Let me try and refresh this. There we go. So this link that I'm sharing with you to my notebook, this is a Google Doc. It works like any other Google Doc. So as I'm making changes, that should be reflected at the same link that I've just given you. If you're not seeing all the changes that I've made, you might just need to refresh the page, right? But this link that I just have given you will be the same link that works after class, that works in the future. It's what's going to be in the DS9 Notepad channel, right? It doesn't change before or after lecture. It's just going to be the same link the whole time. And if you're not seeing all the changes that I've made, you might just need to refresh the page, all right? But we are then ready to go. Let me close some of these other tabs that I don't need right now. And we'll dig in to our first topic, joining data. Well, we first need to get the data set we're going to be working with today. We're going to be working with Instacart orders. Instacart is an online grocery store ordering system, right? So all these data sets refer to, see, when I say data sets, I mean the different CSVs that I'm downloading right now. They refer to a whole bunch of online orders that shoppers have made on Instacart, right? So we have the Instacart tables. These, to be honest, these CSVs probably came from a SQL database kind of download. And you'll see that each CSV here represents a different entity, a different object, right? So they have CSVs that describe the different aisles of the store, the different departments of the store, specific orders and products kind of together here, then specific orders and specific products, right? So what we're going to need to do is we're going to need to dive into these CSVs and learn where the important pieces of information that we need for our purposes, where they're at, so that we can know how to pull the information into one single data frame that will allow us to achieve our goals. But before I point that out here, there's a couple of new bash commands here. Again, you won't be quizzed on these, but I just want to explain what's kind of going on in this section. I'm using wget, just like I did yesterday, and I'm getting a zipped file. This is a compressed file, but it's compressed in a different format. This is what's called a tarball. That's a different kind of zipped format. And tarballs can kind of be a pain sometime. You'll notice that this command here has what are so-called extra flags, right? So I am using a specific method of unzipping it, but like things like verbose here is putting the output here in a specific format. Anyway, this is why I'm not using the same unzip command that I was using yesterday, because this has been compressed in a different way. But you'll notice it matches. Any kind of a tarball, you unzip using the tar command. But this command here is something we haven't talked about yet. This %cd. This is also a bash command, but if a command uses the percent sign at the beginning rather than the exclamation point, this is sometimes referred to as a magic command. Now, this is different in that it changes the memory of my runtime. All right. So I downloaded a whole folder of items, right, in Instacart 2017-1501, but now I'm changing directories into that folder. So instead of looking from outside the folder, I'm now going to have my working directory be the folder that has all of these CSVs in it. If I didn't do this, I would need to add the folder path onto the individual CSVs. This just makes it so I can call the CSVs directly instead of having to give the whole path every time. It's much like, well, it's identical to, right? So I'm here in my command line. Make this a little bit bigger, right? Here's the world's fastest command line demonstration. You can use the ls command, and that will list out the items wherever you're at. So this is showing me my location, and the tilde just means I'm in my home directory, at least if you're on a Linux-based system. This might be slightly different for those of you on Windows machines, but not too different. So if I type pwd, that stands for present working directory. Right, and it shows me, okay, I'm in my Ryan Allred folder. I can cd to maybe my desktop, right? I'm going to change directory to my desktop, and now it says, okay, now you're in your desktop. Now if I type pwd, it says, you indeed are on your desktop. And if I type ls, it will list everything on my desktop, which is usually not very organized, so there's all kinds of garbage on here, right? But now I could, from my desktop, you'll see that there is a Lambda folder. This is where I hold all my Lambda schoolwork. I can cd into the Lambda folder. Then I can look at everything that's in the Lambda folder. Here's all the different versions of curriculum content and other notes and things, right? Anyway, this is what is going on right now with this cd command, right? Is essentially, instead of being outside of the Instacart folder, we're getting into the Instacart folder. We're going to work from within that folder, right? But the % sign here means we're changing the memory of our system, and we're going to change its state, and we want it kind of to be permanently changed. These exclamation points, these shell commands are just running small scripts, but this is kind of changing how the underlying computer that's behind this Google Colab operates slightly. So that's the difference between a magic command and then kind of just any other shell command that runs a simple script. All right, so this is the list command that I just showed to you in my terminal. ls is short for list. And then -lh, these are what are called flags. That stands for long format, human readable, right? I could also put these flags separately, but if you have multiple flags, you can combine them into one, right? So this is just, let me even just take these off and show you what the list command does without those flags. It only shows me the file names. If I put a -l on it, then it shows me the file names, but look at these. This is number of bytes. We don't typically think about things that way. So if I put an H on here, it changes those bytes into kilobytes and megabytes. All right, so that's all these flags are doing. This star here, sometimes called a wildcard operator, it just means give me anything with the file that's appended with .csv, right? So it's looking through the folder and it's grabbing all the different CSVs and outputting them. All right, so that's a little bit of information about what's happening there. Again, you don't have to have this stuff memorized. If you ever end up needing to unzip a tarball in the future, you can even just come back to this lecture notebook, grab this line of code or something like that. Or you can you know, make really organized notes for yourself so that you can kind of have all of your notes in one place. That would be good too. All right. We will use the command line a lot more in the future, so we'll get used to this cd and list command a whole bunch, maybe in Unit 3, for example. All right, but now we're ready to go. I've got all these CSVs ready to go. I'm going to show you the first half of lecture, what we're going to be trying to recreate. We're going to be trying to make this table, all right? Now, This table actually comes from a blog post. It is this 3 million Instacart orders open sourced. No, that's the data set. It is, where is it? Oh, this is it. All right, so you'll notice this is a blog post about Instacart data, and here's this graphic, right? We're going to try and reproduce this graphic, and then there's other things here. Second half of lecture, we're going to try and reproduce some portions of this graphic as well. All right, so this is kind of where some of the ideas for how to use this data set to learn these pandas functions has come from. So you can take a look at that blog post in a little bit. I'll link it to you, even though it is here in the notebook. All righty. And this code here, what it's doing is it's taking this image and saving it as this example. So I'm loading the image into the pandas workspace. So now I just have to say display and then pass in my image, and it will output it. So this makes it so that any other code cell, I can just run this command and it will output the image, right? So I don't have to keep constantly be scrolling back up to the top of my notebook to remind myself what this looks like. I'll just output it down below. So we might end up having this image like 5 or 6 times throughout the notebook as we want to kind of check our work, all right? But here's the 6 different CSVs we're going to work with. First step is we got to see what's in these CSVs. We need to load them individually and see where the information we need in order to generate this table where all that information's at. So that's what we're going to do first, right? And it means a lot of pandas read CSV, all right? 6 different times. So I first need to import pandas. Let me do that here. And now I can say, I'm just going to use data frame names that are the same as these CSVs. So I'm going to say aisles equals pd.read CSV. And because we changed into the directory, I can just give the name of the file. If we hadn't changed into the directory, this would have to be something like this, right? If I hadn't done that magic cd command, I would have to give this as the file name, but because I have changed into that directory, I only have to give this as the file name. So let's do print the shape here and look at the first 5 rows. And I always so used to typing df and typos galore. All right, 4th time's the charm. There we go. So aisle ID and aisle is what is in the aisles CSV. Now, if we come back here and look, do we need anything related to aisles in order to make this table? Particularly look at the column headers, right? Anything referring to aisles. Yes, I can make the font a little bit bigger here. Is that big enough, Mikhail? Or Mike? Now it's really big. That's okay. I'm gonna go one setting small. Hopefully that works. All right, so moral of the story is, well, moral of the story is my notebook's frozen. Give it a second to revive. All right. You don't need anything from aisles.csv. All right. Departments. Now, I'm just going to copy this code and I'm going to change everywhere where it says aisles to departments. I'm pretty sure that there is like a find replace within a specific cell for Google Colab. They've been implementing a lot of shortcuts like that recently. All right, department ID and department. No, I don't see anything related to department. Is it Control H? Is that within a single cell or is it the whole notebook? I think it might be the whole notebook. Oh, it looks like I can select specific. We'll try that here in a second. We'll see if we think it's any faster. All right. So nothing in departments that we need. Let me just make a note of that. This is the laziness of typing that I hope you all develop because you're going to do a lot of typing. All right, let's do Command H. I want to change departments to, what is even the next CSV that we need? Order products prior. So this is a double underscore here. I don't know if you can see that. Two different underscores. So I want to replace departments with order products prior. And replace. Now, I don't know if you thought that was faster or not, but kind of fun. Notice it's taking a minute to read in this file. This is a bit of a larger file. Let it spin for a second. All right. How many rows are in this file? Thousands, millions. 32.4 million rows in this file. All right. Biggest thing we've worked with so far. All right. Now, surprisingly, our collab won't choke on this unless we do some things wrong. Right. So this is getting to the point of file sizes where if I don't organize my code in a certain way, it's going to restart my collab's runtime. It's going to crash the machine that's running this Google Colab. All right. So I'm going to talk a little bit today about what we're going to do specifically to avoid that. You will be using this same data set on your assignment. And so if you don't take care in the same fashion on your assignment, it could also restart your assignment notebook. All right. But moral of the story, we have order ID, product ID, add to cart order, and reordered. Instead of scrolling up, let me just say display example. All right. We need order ID. We need product ID. We need add to cart order, but we don't need reordered. Doesn't look like reordered's in here anywhere. All right. So we need order ID, product ID, and add to cart order. Alrighty. Order products train. Now I'm not going to do the Command H. I don't know it's that much faster just because I have so many instances of this throughout the notebook. If I had a whole lot of them, I would totally do the find replace, but I just don't have that many here. It's just 4 spots. All right. Again, looks the same as up here. Order ID, product ID, add to cart order, reordered. Order ID, product ID, add to cart order, reordered, right? So first question for you all that I want you to try and respond to. Why do you think that these two data frames, order products prior and order products train, might have the same columns? Good, good, good. You're all on top of it. Yes, this is intended to be the training and test data set for a machine learning algorithm, right? So they've taken a small subset, right? We have 1.4 million rows here in order products train, but we have 32 million rows in order products prior. So they've taken something around 3% of the data. What this Instacart data set, what its intention was, or why Instacart released it, is order products train is the most recent order for every individual on Instacart. All right. But order products prior is all of the orders they've made before that most recent order. So this data set was intended to be used in order to help people try and predict the next time a particular individual comes to Instacart, what are they going to buy, right? And so they want to, have some kind of a recommender system so that when that person, when Joe Smith logs in and we can see his past orders, we know we should give him ads for aged white cheddar popcorn and beef jerky because he buys that a lot, right? Things like that, or soda, right? And particularly the order, add to cart order is here. And it seems like this particular person is even consistent in how they shop, kind of the process they go through as they're ordering things, right? So after he's bought soda, well, then I might want to suggest beef jerky. After he's bought beef jerky, then I might want to suggest aged white cheddar popcorn, because even the order in which he's buying things is somewhat consistent. And I think that would be at least partially true for all of us, right? So yes, add to cart order means the order in which it was added to the shopping cart. That's exactly right. That's exactly right. So that's what this data set is originally intended for. Today, we're not going to load it into a machine learning algorithm quite yet. We're going to practice some of these joining and reshaping data operations, and then we're going to make some visualizations. We're going to make some graphs out of it. All right. So basically, because these hold the same pieces of information, I'm going to end up concatenating them together, or I'm going to take these two CSVs and I'm going to make them into one CSV that all has the same columns, right? But I'm just going to take the rows of order products train and add it to the rows of order products prior, hold it in one CSV by the concatenation function. All right. But we still have to look at two more CSVs here. We have orders. All right. And there's quite a few things here that we need. I think, again, we have order ID repeated. Do we need user ID or eval set? Well, we do need user ID. It looks like we don't need eval set. Order number, order day of the week, and order hour of the day. I think we need all three of those. Number, day of the week. That's what DOW stands for, day of the week. Order, hour of day. So we need days since prior order. Do we need that? Doesn't look like that's included. All right, so I'm just looking through these CSVs. Where are the columns that I need currently at? You kind of see it there. They're a little bit all over the place. We're going to finish off looking here at the product CSV. I spelled it wrong. All right. So we got product ID, product name. We already verified that we don't need anything about aisles or departments. So I think I just need product ID and product name. All right. Why do I? All right. Consistency here. Also called being OCD about your notebooks. All right, that's okay. All right, at this point, we know where all the things that we need currently live at. But before we jump into actually putting all this together, I want to talk about these CSVs a little bit, because these CSVs are organized very specifically. All right, you'll notice that each CSV corresponds to a specific entity, a specific thing in the store. So each product gets a product ID. We have its product name, and then it says what aisle and department it lives on. This is all the information about a specific product. And each row in the products CSV is a different product. All right. In the orders, each row in the orders CSV is an order. It says there's a unique identifier for each specific order, the user who ordered it, whether it was in the products train or products prior data set here. This is not important to us because we're not using it as a train test data set, and also when did the order happen? Which the order number for this specific user. So this is the first order for user 1, second order for user 1, third order for user 1. Day of the week, hour in the day, and the number of days since prior order. You'll notice that this is NaN for the first order because there is no prior order when the person makes their first order. All right. The most important, let me see. Yeah, we don't need aisles and departments. So we're only going to look at 4 of these CSVs. I think order products, which is what's going to be after we concatenate order products prior and order products train, I think is the most important CSV of this whole lot, right? So why do I say that order products, which is what it's going to be after we concatenate these two, or order products prior, order products train? Why might I say that this table is the most important of the 4 that we're going to look at? See if this makes sense. And the reason why I'm asking this question is because whenever you know that you need to merge data sets, I want you to look for something very specifically. Well, so, for today, we're not going to be making any predictions about what the customer is going to buy next. So we might still use some of these, but that's not our ultimate goal. Our ultimate goal is just to make this table, right? The reason why I think this is the most important CSV is because it has 2 IDs in it. It has the order ID and the product ID associated together on the same table. This means if I wanted to have any information about products and information about orders and be able to match them up, I have to use this table in order to do the matching, right? Because this tells me what products were associated with what orders. So when I'm merging data frames together, notice this table, I need information both about orders and about products, right? How am I going to be able to match this information together, right? Well, I have to have their IDs associated somewhere for me to be able to know how to pull those in. So when we're merging data frames, which we'll do here in a minute, what I want you to pay utmost attention to as you're kind of going through this process of looking through CSVs is ask yourself, where are the unique identifiers for my rows at, right? So you'll notice in the products, we had product ID. In the orders, we had order ID. But in order products, we had both the, where am I at? Here we are. We had both order ID and product ID, and that's why it has the name order products. We got orders, we have products, we have order products, right? This is, if we did not have this table, we would not be able to join these data sets together, all right? Now, this, coming from kind of SQL parlance, is sometimes called a join table because it has IDs from both of the things that I might want to pull together, might want to join, and so just be aware of that and paying attention to specifically where are the unique identifiers for rows at. Now, when we're fitting a model, I don't so much care about the unique identifier as much. It might have something to do about like with when when something was ordered, but it's typically not going to be hugely valuable to a machine, valuable to a machine learning algorithm, but it is very important for our data cleaning, data munging, data preparation, in pulling these data frames together. All right. So, and we will keep on using these columns. So important to know where they're at and pay particular attention to them. All right. So we're ready to concatenate order products prior and order products train, and this will be, I think, surprisingly easy to you. This is the first of the 4 pandas functions we're going to talk about today. All right. So we are, first off, we're going to look at order products prior, and we'll look at its shape. All right. And we'll look at order products train.shape. Now, what I want is I want to add the rows of order products train to order products prior and then I'm going to make a new data frame, and I'm going to call that new data frame, I'm just going to call it order products. All right. But I want to verify that once I do this concatenation, that what I end up getting is the sum of the number of rows here. So this plus this will verify to me that I've concatenated this correctly. All right, so I'm going to say order products equals, and then the function here is pd.concat. So it's a pandas data frame, a pandas method, and it's called the .concat that we're using here. Oh boy. I don't know how I put parentheses around that. Now, what I want to do is I want to give this a list of data frames to concatenate. Concatenate is a fancy word for append to one another or stick together, right? So first I want to give it order products prior, and then I want to give it order products train. A little bit of autocomplete magic there. And let's verify the shape. It's not a method. All right. Now I can eyeball this, and I can maybe even do a little bit of math and see that this has worked correctly. All right. The concat operation has works in two ways, right? So let me show you what we've got here. All right, so I have one data frame and I just added rows together, right? Take the rows of one data frame, put it at the end of the other data frame, right? This is the default behavior of pd.concat, appending by rows. So here at the top of the notebook, there's a link I wanna look at quickly. It's called this pandas cheat sheet, and I'll also link to it in Slack here. And we see here we're working with pd.concat. We're in the reshaping data section. We can concatenate by rows. This left-hand side, this is what we're doing right now, right? And we did exactly what it says here, pd.concat, a list of our two data frames. What I want to show you is that there's another behavior of pd.concat where instead of concatenating or adding rows together, it will add columns together, right? So you'll notice that this one has 2 columns, this one has 3 columns. You end up with something that has 4 columns because these 2 columns were the same, all right? But we have to pass another parameter, axis equals 1, in order to concatenate by columns. Remember, our data frames always have this property, axis equals 0 technically refers to rows, and axis equals 1 refers to columns. We had to do this same thing when we did df.drop. We wanted to drop columns. We had to say axis equals 1, but if we didn't say anything, the default was axis equals 0 to drop rows, right? So I want to just show you what happens if I do axis equals 1 here. I get back down to it. Okay. Now, the shape here is not the number of rows added together. It's the number of columns added together. And what it's done, it's taken the columns from one and the columns of the other, and it's just stuck them together, right? This is the second behavior of pd.concat. This is actually not the one we need, but I just wanted to be really explicit that we can concatenate in both these ways, adding columns together or adding rows together, if we specify that we want to specifically use columns. All right. Notice that this gets the length of the longer data frame. So if I scroll down to, well, I'm not going to scroll down to it, but if I were to scroll down to row 1.384 million, after that, we would start to see NaN values here on these 4 rows, and be NaN values down to the end because this data frame wasn't as long as this data frame. And so it kind of runs out of values before the other one does. All right, so those are the 2 behaviors of pd.concat, but I, for today, obviously don't want to do it based on columns. I want to do it based on rows. All right. So I'll use the default there. Another thing that I want to use this as a good excuse to show you. We try and wrap up the first half of class before the break, so I think I'm kind of on track for that. Frozen notebook. All right. I want to show you about assertions. Right now, we're not going to get into like testing our code a lot until kind of unit 3. In fact, the brown bag that's happening right after this lecture is going to talk a whole bunch more about what I'm going to very briefly introduce to you here. I want to just introduce the assert keyword. All right. What assert does is if we give it a statement afterwards, right? Here's a conditional, right? If that conditional is true, then assert does nothing. But if that is false, it throws an assertion error. All right. So this is one of the very, very first things I'll show you about how to test your Python code. Now, why might I want something to throw an error on? That's the desired behavior here, is that if this statement evaluates to false, throw an error. Well, maybe I have a whole data pipeline, right? I have a whole notebook, and maybe it's not even in a notebook, it's in a Python file, so that this is just gonna run from top to bottom and I can't stop it, right? What I wanna do is I wanna check specific properties of my data, and I say, okay, if these two have been concatenated together correctly, then proceed on to the next few steps. Maybe the next steps right after this are really time consuming. Maybe I have a machine learning algorithm that's gonna train for 2 days on a GPU and cost thousands of dollars of machine time to run, right? I wanna make sure that everything is completely ready to go before I kick off that process, right? And so I can use assertions to check and say, is everything ready to go? Are all the things that I expect to be in place the way that I expect them to be before I move on to this really expensive kind of big process, right? So I can use assertions that if things aren't ready, it'll throw an error and it will stop the program, all right? Evidence asks a good question up here above. I'll come back to assertions here. Why didn't it combine order IDs together? I think let's wait for it. I think it might have. It's kind of hard to see here. Let's look at maybe a whole bunch of orders. Or maybe there's even another parameter I'm missing. Oh, and it crashed my notebook. All right. 1 second. This is something you might run into more than once today. I'm just holding down the shift key while I hit enter. Shift enter will automatically run a cell. If you didn't know that, that's the keyboard shortcut. You don't always have to click on the play button. You can do shift enter. But I'm reloading all these files here from the tarball, so it's going to take a second to get caught up. All right, there we go. Now, does it say the eval set? So here's the thing: is it would have combined based on order ID if these numbers were the same. All right, but we don't have any repeated order IDs between the two data sets, right? So because there are no repeated order IDs, it didn't combine these at any point. All right, so that's the reason why in the cheat sheet, these two gray columns become one column if they have the same values in the cells. Also, when I add it together, why is this floats instead of ints? What do you guys think? What's one reason why things that I expect to be ints sometimes show up as floats in a data frame? Yeah, exactly. Because this data frame was shorter, and when I get down to row 1.38 million, I'll have nans below that. And if I have nans in a column, then things become floats instead of integers to try and maintain the same data type throughout a column. Yeah, it's because of the NaN values here. It's basically because this data set is shorter in the number of rows than this data set. I've got a whole bunch of floats when I was expected ints. Good, good. Awesome. So basically, these order IDs didn't get combined because they have different order IDs. If they had the same order IDs, they would have been combined. Alrighty. I'm going to use a really simple assertion here, and I'm going to say, I want to make sure my concatenation has happened the way I expect it to happen. I'm actually going to comment out this assertion because I don't like errors in my notebook. At least I don't like the look of them. They're fine. I mean, that's the point of the assert function, right? But I'm going to ask if order products prior dot shape 0, so that's specifically only the row value here, plus order products train dot shape 0, if that's equal to order products dot shape 0. All right. Let's see if this assertion is correct. And it ran and didn't throw an error. So this must be the case, right? I am testing whether or not this is a true statement or not in my notebook. You'll probably hear some much more sophisticated ways of doing this in today's brown bag if you tune in. But all those brown bags do get recorded. If you absolutely can't attend, you can watch it after the fact. I misspell everything, Stephanie. I misspell everything. So anyway. All right. That's the end of our concatenation section. Remember, pd.concat, we're just adding by rows or adding together two data frames by rows or by columns. That's one of 4 functions today. All right. So next, we want to merge data frames, and we're going to use the pd.merge function for that. But before I do that, I need to specifically see where the information I need is at again, remind myself of that. And I need a unique identifier in both of the data frames that I want to merge to help match pieces of information together. Right, so when I'm merging things, what's really happening, if I can kind of scroll up here, forgive the abrupt scrolling, and let's look at the difference between, let's see, order products train and orders. Let's see if I can get both of these on the same screen for a minute. All right, so what's going to happen is imagine I'm merging orders and order products. Well, it's going to say, I want to match these based on their order ID, right? So I have order ID here, and I have order ID here. We're going to start with order products and say, okay, order ID 1. Which rows in this data set have order ID 1? Loop through the whole data frame here, find where order ID 1 is, grab its values on its row, and add them to this row. Then move to order ID 2 and look through this whole data frame for order ID 2 until I find it. Then I grab its rows and add it on order ID 2 here. Then I look for order ID 3. Look through this whole data frame until I find order ID 3, grab its rows, and add them to this data frame, right? So what I'm trying to emphasize here is that this is a computationally intensive thing to do. There's a lot of lookups happening, and there's a lot of copying of information between data frames. Yeah, I'm trying to make it sound like a lot of work because the computer is just going to do it for us, but it's really doing a fairly complicated procedure under the hood. All right. Now, the reason why I'm belaboring this point is because if I try and merge my entire orders data frame with my entire order products data frame, it will crash my Colab. That is a ton of lookups. And so before I do this process, I want to see if I can limit the scope of this merge, see if I can make it smaller so it doesn't have to do as many lookups. So what I'm going to do is first, let's remind ourselves of what we're trying to make here. Let's look at our example. I only need 2 order IDs. Order ID 2539329 and order ID 2398795, right? To make this table. For my purposes, I really only care about 2 orders in the whole data set. So why merge every single order if I only end up, if I'm going to throw away, 3.24 million of them, right? So what I'm going to need to do before I do this merge operation is I'm going to need to filter these data frames down to the pieces of information I actually care about. And that's going to make it so that this, this merge operation does something like 200 lookups instead of like 200 million lookups, right? It's going to make this process much more tractable from a computational load standpoint. Now, in the future, we will have 1, maybe even 2 full units about computer science. And those units are all about thinking about these kinds of problems, talking about things like big O notation, which refers to how efficient is a specific process. This is one of the reasons why a lot of processes in Python and in programming in general rely around dictionaries. Dictionaries have extremely fast lookup times, and it's another reason why for loops are generally avoided. This is why we used the .apply function yesterday instead of writing our own for loops to apply to make changes to columns, because the .apply function runs much more memory efficiently than a for loop does. Generally, you can do a lot of things here with data frames with for loops, and we won't shy away from them. But typically, there's more memory efficient ways to do things. So even here from the very beginning, we will try and introduce some of those things. Your session crashed after using all available RAM. Yeah, if this is the message you'll get if you don't subset your data frames before you merge. All right, let's switch to a high RAM runtime. Why not? Thanks, Google, for the free computers. I don't know. I don't know if they'll keep Google Colab free forever. But kind of cool that I can even, if I come here to runtime, I can even say, hey, use a GPU hardware accelerator for free, which is kind of bonkers. And I can't imagine how much this is costing Google. But no, don't worry about your for loop dreams. You can still use for loops. So they're quick and dirty, good ways to do things. But almost always where you're using a for loop, there's typically a better way to do things. Anyway. Christopher says, thanks to more, the actual computation may be the cheapest part of the operation. That's true. That's true. We have the time of 40 people looking at this. Think about the economic cost of 40 people watching one single merge happen together. Anyway, that's same thing about business meetings. Anyway, I need to stay away from tangents because I gotta finish this up before we end the first half of lecture. All right, so let's get back to merging here. All right, so first off, I want to remind you about data frame filtering. Here's a little bit of a review. All right. We're up here. Get a subset of orders, the first 2 orders for user ID 1. All right, so here is a condition, right? I only want to see where order products with this order ID equals this specific order ID, which I grabbed from right here, right? And let me show you what this condition ends up looking like. Why is order products not defined? Oh, did my runtime crash again? Oh boy. Bear with me as I hit enter a bunch of times. Goodness me. All right. Wait for it. Where are we at? All right, there we go. So here's what this condition ends up looking like, right? Well, we have 1 row in our data frame for each specific order ID. So what's really happening is somewhere in this data frame, around the number 2539329, there will be 1 value of true. somewhere in this truncated part, right? Everything else is false. And the false things here refer to all the things that we don't need, that we could be merging on, but that we're going to discard, right? So what I'm going to say is, what if order products ID equals 2539329, or order products ID equals 2398795. Truth value of a series is ambiguous. Wrap our conditions in parentheses. All right. Same thing, but now I'm going to have two true values, one where the order ID is this and one where the order ID is this. This is a condition that should allow me to filter my order products data frame down to these two pieces of information. So let's try it. So I'm going to access specific things from the orders data frame, and I want to access them based on these conditions. So it will only retain the rows where this evaluates to true. It's an odd user warning. It's taken a while. Remember, it has to loop through all the different rows here and decide, keep that row, throw it away. Keep that row, throw it away. But I might have done something wrong. Cannot reindex from duplicate access. Oh, I need to be looking at order products. Thank you, Eric. There we go. All right. And now let's maybe look at the first 20 rows. This is the start of the table we're trying to make, right? We notice we've slimmed this down to what we actually want, right? One order, two orders, and it's starting to look like the table in our display example. Alrighty. So I'm going to save this to a variable. What should I call that variable? Oh, by the way, again, why am I using this bitwise OR operator, sometimes called as a pipe, instead of the spelled out OR here? Why is that the case? Because it's fancier. That is true. It is a little bit fancier because it's one character less. No, it will break if I do this. Right? The reason why I'm using the bitwise operator here is because I use the spelt out OR when I'm comparing single values on the left or the right hand side. I use the pipe, the bitwise operator, if I'm comparing lists of values. So I've got a list of trues and falses over here, and I've got a list of true and falses over here. What this is doing is it's comparing items in both of these lists, and if either one, if it's true in this list or this list, then it will be retained. Right? So when you're doing data frame filtering, you'll typically use the bitwise AND operator and the bitwise OR operator. You will not use AND and OR, but you will use the spelt out AND and OR in if statements a lot, right? Notice that they're just for two slightly different types of comparison. Am I comparing individual values, or am I comparing lists of values? That's the differentiation. All right. I thought I wanted to save this to a data frame. All right, so this is a subset of orders based on the order IDs. I also want to get a subset based on a subset of based on users. So let me show that quickly. I've got orders, and from the orders data frame, I want orders where the user ID equals 1. Is that right? No. Well, let's just look at this first. All right. During handling above, another exception occurred. Orders. What's wrong? My runtime didn't restart again, did it? Oh, my square bracket needs to be there. Sorry. All right, so here's everything from user ID 1, but you notice user ID 1, the first person to ever order on Instacart, is made more than the 2 orders we care about. Here's the first order we care about, and here's the second order we care about, right? I don't really need all these other orders, so I need to slim this down even further. So I'm gonna filter this, and then I'm gonna filter it again, all right? So I'm gonna pass a second condition here. So I'm gonna filter on this condition first, then I'm filter on this condition second. This is something we haven't done yet. We haven't filtered twice in one go, but this is a lot like chaining of functions. I also want where order number is less than or equal to 2. That right? Yes, I think that's right. And order number. Can you use the bitwise operator for single values? You probably can. This is a really silly example. So I basically just made conditions where only one of these is true, right? This one is false because 1 does not equal 2, but these ones are both actually 3. So 3 equals 4. So one of these is true, the other is not, in order to test an OR statement. If we're seeing this printed out, it means that the bitwise operator works for single values as well. And we're not seeing it printed out. So that tells me we need OR here. So that's a quick test, but it looks like it doesn't work in both cases. Now, if I put these in as lists, it might work. Unsupported operand types. Not sure what's going on. There we go. So it works if they're lists, if it doesn't work if they're individual values. So bitwise operator, things that are iterables, lists, dictionaries, data frames, range values, anything that could be looped over should work for anything like that. We typically only use it with lists, but anyway, I'm going to comment this out. I'm going to leave it here for your curiosity, but it's commenting it out to make sure you realize it's not part of our actual code. And yeah, I realize you're using this question around minimal Python. It looks like you're going to need to know both. There isn't one that works in every situation, and the other one doesn't work in some situations. Okay, so at this point, I have order products slimmed down to what I need it to be, and I have orders slimmed down to what I need it to be. All right. You'll notice that there's still some columns here that I don't need. For example, I don't need reordered, and I don't need eval set or days since prior order. So I still, this is not the slimmest, most slim version that I can need, let me show you what I'm going to do in order to completely slim this down. All right, merge. This is above was me showing you how we're going to slim this down so our merge doesn't get overwhelming. Here I'm going to actually do the merge. So a subset from orders with order products, right? So here's my condition that I want to filter on. We established this up above. This is going to be exactly the same as above. I went where user ID is 1 and orders is less than or equal to 2. That's this guy, right? That's that condition. And I also want a specific set of columns because I don't want all the columns retained. I only want a specific subset of columns. So I'm telling it the columns I want to keep here. And that went over the 80 character line. So I'm going to reformat this like so. All right. Now, to get my orders subset, the only the pieces of information I need from orders, I'm going to use the LOC function, and this allows me to both filter. This is something we haven't talked about yet. Filter based on this condition, and subset based on these columns. All right, so this is going to do both of these operations. It's going to do filter based on this condition, and then only retain these columns. This is a little bit of the magic of the .loc call, right? There we go. Only the columns we want and only the rows we want. That's basically what we're saying. Give me the rows that I want, give me the columns that I want, throw everything else away. All right. We want to do the same thing here for order products. Let me scroll up for a minute. For order products, we only cared about these two order IDs. All right. So I'm going to say that my condition here is this, all right, with the OR operator. And let me just add a new cell here. And my columns are order ID, add to cart order, and product ID. And I'll format this the same way just for consistency. All right. Same thing. My order products subset equals order products .loc. Only give me from this data frame the rows that I want and the columns that I want. Oops, what did I do wrong? Why is everything nans? Oh, I didn't run the columns. Thank you. Got to run your cells. And add to car order is not a thing. It's add to cart order. I mean, they're delivering this to your house specifically so that you don't have to put it in your car. All right. Now I have slimmed down before I'm doing the merge to only the pieces of information I care about. Now I'm finally ready to merge. All right. Because I have slimmed this down, my merge will be not too bad here. I'm still going to include some variables, some parameters here that are the defaults, just because I want you to be aware of those parameters, but they're not necessary truly for me to add them, right? So what do? I give it the left data frame, right, which is orders subset, yeah, and then order products subset, right? So merge these two data frames together. And then here's the two parameters I don't actually truly need to specify here, but I'm going to do it anyway. How equals inner and on equals order ID. All right, let's talk about these two parameters. These two parameters are going to be the hardest thing to understand about the merge function today. And I think the merge function is probably the hardest topic from today. All right, so if you can dig in after lecture and really wrap your brain around these two things, you'll be in a good spot. Now let me explain what they are. How says what kind of merge to perform. Now there's lots of different merges, and I'll share some materials with you after class. Types of merge pandas, right? This is my favorite one. All right, here's the different types of merges. A left join, full outer join, a left join if null, inner join, right join null. Now the default functionality of this method of pd.merge is to always do an inner join. What this means is grab the intersection from these two data sets, right? If there's something that doesn't match between either one of them, just drop it. What this really means is, because we're merging based on order ID, it says, okay, if you see the same order ID in both of these data frames, keep those rows. If there's an order ID that exists in this data frame that doesn't exist in this data frame, then drop those rows, or vice versa. But because we slimmed this down, we don't really need to drop anything. Because we slimmed this down, an inner merge will do the same thing as a full outer join merge here because of our slimming. And that's a good place to be in, where you have limited the information to exactly what you need. It makes merging easier. What's the difference between concat with axis 1 and merge? A lot of different things. The shape of the data mainly will be quite different. What I'm going to do is, I wish I had time to really demonstrate and give examples of both of those here, but I'm kind of over the halfway mark. How about this, Christopher? After lecture, I'll put together a little notebook and I'll show some examples of merge with the same data set and some examples of concat with the same data set, and you can kind of see how the end results end up looking a bit different. You could probably use merge for concatenating, but it would be a little bit of a pain. Anyway, so I'll get back to that question. All right, but moral of the story here is that because I've slimmed things down, my how function here is going to work really cleanly. But to be clear, inner here is the default of this function. So if I didn't specify it, it would do an inner merge. I'm just specifying it here to be really explicit about what I'm doing. Okay, on, what does the on parameter mean? The on parameter is like, what is the ID column that I'm going to use for doing the matching between these two? Well, in our example, it's order ID. We have order ID here, and we have order ID here. That's how you're going to match this information. So it's going to start here with the leftmost data frame, and it's going to say, okay, here's my order ID. Now go and grab the pieces of information from here that have that order ID, which I think this actually needs to be bigger. Yeah. And then it's going to go to the second row, and it goes to say, okay, here's this second order ID. Now go look for things that have that order ID here and pull in their information, right? It's kind of doing this nested for loop where it's looping through this whole data frame for each individual row of this above data frame. You could write your own merge function with nested for loops. I don't recommend it, but you could. All right, so let's look at merged. What? Commas? Who needs commas? All right. At this point, I'm pretty darn close to my example. The only thing I don't have is I don't have product name, right? Well, how am I going to pull in product name? Well, I'm going to do it based on product ID, which means I need to do one more merge here. All right. And I'm going to call this last one final. It's always dangerous to name a data frame final because you'll end up with final, 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 final one, final two, as you realize that it wasn't really the final version. But I know this is the final version because I've done this before and I have the notes. So, all right. So from products, I'm going to just filter this one in line here, right? So I'm just going to say, only give me these columns. I only care about these two columns from products. I'm going to filter that right away based on those columns. And then again, how equals inner, on equals product ID. Unless, yeah, how many rows are here? 10 rows, 11? At this point, we're pretty darn close to our example. All right, so there's a few different things. We've got underscores in our titles here. This is sorted a little bit differently. It's sorted by order number, then order day of the week. So that if I want to be really a stickler here, I will sort this and then replace these underscores with spaces in the column headers, right? Column.replace for column in final. This is a list comprehension. They can be really slick, basically combining a for loop and looping over a list into one single one-line statement. This is a Python specific thing. Other languages don't have this. I think this is one of the coolest things about Python. Anyway, you can dig into it. And at this point, we're pretty darn close to our example. I don't know if you can see both of those on the same screen. All right. So we have achieved the goal. It required both concatenating and merging. You want me to scroll down? Oh, up. Mary, you're motioning. There. Okay, gotcha. Yeah, so this is the column renaming replace, and this is the sorting, right? Kind of just housekeeping things at the very end. But the merge was the big deal here. The mergings are what I want you to focus on. Remember, we were slimmed down things before we merged to get as concise of a data set as we could. And we also kept track of the order IDs and product IDs. Those were the most important columns because that's how the lookups happened and the matching happened between the two data sets, right? I need some unique identifier that exists in both of my data frames or I can't merge, at least successfully. All right, we are at 11:21. We're gonna take a 5-minute break. And when we come back, we're gonna talk about reshaping data and we'll have to go a little bit fast. So I will see you back here in 5 minutes. All right. Come on back and we will get going again. John asks, if we missed something during live instruction, is there a way to review the changes in the original lesson collab before waiting to see the upload video from the day? Yeah, so you can use the link that I shared at the beginning of class, and it should have all the code that I've typed during lecture. You can compare that to the version on GitHub, which was how it was before we started lecture. Does that answer your question, John? Yeah, it should autosave every time I run a cell. Yeah. If you're getting that key error, Eric, make sure that you have run all of your cells. I think I got something as well. Make sure your columns are typed correctly, your column headers as well, and that you've run all of your cells, because I think I got a similar key error. But if you have the Colab notebook here, you could refresh it. You should be able to get the code that I have, and if you really can't figure it out, just copy from what I've written to the version you're working in. All righty. Let's move on to reshaping data. All right, so that's a brief introduction to merging and concatenating data sets. We have two more pandas functions to go over today. One called pivot and one called melt. Now, the cool thing about these is they're opposites of each other, right? So one takes data from tidy format to long format, and the other takes data from long format to tidy format, right? So they will undo each other. It's how we go back and forth between these two data formats. But what do I mean when I say tidy data format? We're going to look at this paper by Hadley Wickham. Hadley Wickham's a pretty famous statistician and data scientist. He actually got a big award a couple months ago for his contributions to the field. But he comes really from the R universe. He's been a big player with the R programming language, and has done a lot to further data formatting, right? So tidy data is kind of his thing. And this is his article, kind of introducing tidy data formatting. Yeah, Mr. Wickham, this is not a Pride and Prejudice. Anyway. So tidy data formatting. And I hope you would look through this a little bit later today, this article. So here is sometimes how we typically have data in a data set, right? This is our index here, a unique identifier for each row. So typically this is integers for us, 0, 1, and 2, but it could be people's names, right? If we didn't have any repeated names in our data set, these could serve as a unique identifier and could serve as the index of our data frame, right? Then we've got our column headers for the two treatments, 2 different times we collected information from these people, and then some numbers referring to the outcome, right? The measurements here, right? And this is typically how a data set exists. The argument for tidy data and for not using this data format is that we want columns to represent a single variable, and we want rows to represent a single observation, right? So you notice that I have John Smith in treatment A and John Smith of treatment B. Those are 2 different observations. Those are 2 different events of things that happened to John Smith. But right now they exist on 1 row. They should be on 2 different rows. And you also notice that my treatments, treatment A and treatment B, happen in 2 different places, when maybe I want all of those important pieces of data to be on a single column. And if they are in a single column, then I can access them with a single column header. I can make plots using that single list of values much easier, right? So really the goal here is take these values that are kind of in a square, in some kind of rectangular grid, and get them into a single vertical column. That's why it's called long format, right? Because it's long, it's very vertically oriented. And that's also called tidy data format. So if you hear somebody say tidy data format or long format, they mean the same thing, all right? So first off, here's a different table. This is table 2. What is the difference between table 1 and table 2? If you look at it for a minute, can you see relationships between those? And while you're thinking about that, My wife calls Pride and Prejudice and all related type movies bonnet movies. Anything from eras where people wore bonnets. She loves that category. All right, so the difference between table 1 and table 2 here is table 2, correct, is the transpose of table 1. All the transpose means is we've swapped rows and columns, right? So the columns here are rows here. The rows here are the columns here, right? Same data, but a transpose. And like, I think the argument here is like, what is the differentiator between why we would make a data frame like this or like this, right? Like, because there's no clear definition of observations and variables, he's making the case that this format makes no more or no less sense than this format, but tidy data format will truly isolate our data types here. All right. So anyway, there's more here in this article. I'm not going to read through all of it. Please do take a look at it. At least read some of the first 2 or 3 pages here. Here is a table that is finally tidy data, right? So the variables are as columns and the observations are rows, right? So we have name, treatment, and result. Those are the 3 aspects or attributes of this person that we're measuring. We're measuring their name, or recording their name, or recording which treatment they underwent, and recording the result of those treatment. Realize that these columns now represent features or attributes in a much cleaner way than here. All right. And also, we have repeated values here. So we have John Smith's here and here, Jane Doe's here and here, Mary Johnson's here and here, right? But all the important data, the numbers are now all in a single column. And that's really one of the best attributes of tidy data, is that we can access all the important values with a single column header. All right. And that's what makes it good for graphing. So tidy data in the R programming language has led to what's called the tidyverse. All right. And the tidyverse means a whole host of programming packages and libraries that have been built to work with tidy data. So this paper really set the standard because of that a lot of other libraries work on. So tomorrow we're going to look at a plotting library called matplotlib. And matplotlib is kind of the core and most basic, most fundamental Python plotting library. It's important. It's really important to know. However, there are more powerful plotting libraries out there. Matplotlib gives you fine-grained control of your plotting, but then there's a library like Seaborn, which is also a Python plotting library. But what Seaborn is it's using matplotlib code and bundling it up into predefined functions, right? So if I call a Seaborn function, what it's doing under the hood is it's using matplotlib code to build that graphic, right? Instead of me having to write out all the individual lines of matplotlib code, I can now just call a single Seaborn function and get all this default functionality, right? But Seaborn is using matplotlib to generate its graphics. Seaborn is a member of the tidyverse, right? So Seaborn works really well with tidy data. You're going to learn matplotlib and you're not going to like it a whole bunch. And then you're going to use Seaborn and you're going to go, oh, this is so nice. But you're still going to need to use matplotlib, because if you want to do any customizations to a Seaborn graph, you have to fall back to matplotlib code, right? You have to fall back to the underlying core library. So that's why we're using matplotlib tomorrow. But over time, we will use a lot of Seaborn. Ryan Herr of Unit 2 is a particular fan of Seaborn, right? And so if you have tidy data, it's going to work really well with Seaborn in particular. So I'm going to show a couple of Seaborn examples at the end of this lecture. But the thing I want to point out is that really the hallmark of tidy data is that the values you need, they're in one column, right? So I'm going to show actually a few different ways to achieve the result of having the values you need in one column. One of those options will be using tidy data, all right? And then we'll go back and forth between tidy and long format using the pivot table or pivot table functionality. Those are 2 different functions. They're almost the same function, so I'm going to refer to them as the same thing for today. All right, so we have table 1 from the Hadley-Wickham paper. We have table 2, right? Table 2 is just the transpose of table 1. All right. Are we going to learn how to transform untidy data to tidy data? Doesn't even matter. Yes. So you will use the same function to go from wide format to tidy format as we will from untidy format to tidy format. Basically, the function that we're going to use for generating tidy data format, it needs specific parameters. It needs to know one parameter: what is the index column, what is the variable column, and what are the columns that have the numbers in them, right? So as long as we give those three parameters correctly to this function, it doesn't matter what format the data was in previously. It will be able to make it all happen. What does matplotlib inline do? It fixes the back end of matplotlib. It's a good practice to add it in. I don't always add it in. Here is a good Stack Overflow post. I've given this Stack Overflow to students in the past, which is why it's already highlighted on my Google search. But this has good answers, so I'll refer you to that for now because we're running low on time. And if you guys want to get to the brown bag, I don't want to go way over time today, so that you can get to that. All right, so let's do this. We're going to go from table 1 to tidy data, just like Hadley Wickham did in the article. In order to do that, we need to do a couple of things. All right, so first off, I want to show you that we can access specifically the column headers of any data frame like this. Right? Oh, I've got to run my cells so that I actually have this data in here. All right, now I can show you, here's the column. So this is called the column index, right? If I make this a list, instead of, it will pull these specific columns out of the index and just show them as a list. All right, I might need these. And I'm also going to show you the actual, the row index, which instead of being .columns is .index, right? Same thing, but this is the row index instead of the column index. All a data frame is a bunch of values with a column index for accessing specific columns and a row index for accessing specific rows. All right, so I'm going to do this toList as well. And now here's the row index. You'll notice that my row index here is the names, just like it was in the Hadley Wickham paper. Now, this index acts a little bit differently than a column of my data set. In order to use the function I'm about to show you, I don't want this as an index. I want this as a column of my data frame. So the way that I can take this index and turn it into a new column on my data frame is using the reset index function. All right, what this will do is pull it in as a new column, and it's going to reset the index to here to be 0, 1, 2. It's the numeric index that we're a little bit more used to when we load data sets. Now I accidentally ran this twice, so I added 2 columns. Let me fix that. All right, there we go. Okie dokie. So that has just taken it from I want to show you both versions here. From this to this. That's what the reset index function did. All right. Made the index a new column. All right, at this point, I've got everything as columns. I'm ready to turn it into tidy data format. Ready for this? I'm going to use the melt function. So I'm going to call this data frame tidy, and I'm going to say table1.melt. All right, and then here's what I need. Well, what is the ID column? Well, that's my index column, right? The thing that used to be the index, that's my ID now. Where are the values at? Well, those are in both treatment A and treatment B. Right, so notice I'm just telling the melt function where the information is at, right? Where's the index at? Where are the values that I want to put in a single column? Where are they at, right? And now it's in tidy data format because it's pulled the repeated index and it's assigned these column headers as treatment A and treatment B, and it's pulled all the values into a single column. This is the most important thing. The numbers in a single column, all right? But notice that all that this melt functionality is doing, all that these parameters mean is tell it where the data is. Tell it where the columns are, all right? What if there were hundreds of columns? It would be harder. If there were hundreds of columns here, I would have to generate a list of columns somehow, maybe with some kind of a for loop, appending column names. I'd have to get a little bit, I wouldn't be able to just type it out here, right? But we can do it. We can do it. All right. So this is still not completely fixed. I'm again just going to be a little bit OCD and fix a couple of things here. I'm going to rename some of these columns to more closely follow the Hadley-Wickham paper. And then I'm also going to replace the word treatment here with the with a blank string. So I'm going to remove the word treatment basically, right? And now this is exactly the Hadley-Wickham example. Anyway, this is all tidy data format. This is just a cleaned up version to match what he had exactly in his paper. All right. So part of your assignment today is to take table 2 and turn it into tidy data format. Right. Go take the transposed version and see if you can do it. Now, to be clear, the way that I don't want you to do this is I don't want you to say table 2.transpose and then do the same thing we did to table 1. Right? This is cheating. Because all this is doing is it's taking table 2 and turning it back into table 1 and then doing the same thing we did on table 1. Right? This is easy, but this is not what we mean. So I'm going to say, don't do this. This is cheating. It's not really cheating. If I were doing, if I really cared about getting this will get the same end result, but this will, the point of you doing this is to learn about these parameters and learn how to set them correctly, right? And if you're just transposing it back, then you won't really get the opportunity to learn what these parameters need to be. All right. Now we're going to go back. We're going to go from tidy data format back to table 1, back to kind of our wide format. And we're going to use the pivot table function for that. There's really 2 ways to do this. There's a pivot function and a pivot table function. I believe the pivot table function can do everything the pivot function can do. So if you're minimally sufficient pandas, this should be the one to use. I believe the pivot table function allows us to do multiple indices and multiple columns here. We typically won't have a pivot table we need to generate that's that complicated, but it will allow us to do things that are more complicated. All right. So here again, I need to tell what the index is, but my index is now called the name because I renamed it. Where are the columns that I want to generate? Well, those are the treatment columns. And where are all the values at? Well, they're in the results column. All right. And we're going to call this wide format. All right. Now you'll notice it does look a little bit different. We have what's called a hierarchical index here on the columns. It means we have a nested index, but don't worry a ton about that. The main thing to see here is that the index and the values are the way we expect. All right. I could do some other cleaning up of this, but we're gonna call this good for today, given our time constraints. Also, part of your assignment, go from tidy data format back to table 2. Right. So you're doing the same things I've done here, but use table 2, use the transposed version to practice it. All right. And now to kind of wrap things up, I want to show you how tidy data formatting works really well with Seaborn. Alrighty. So I need to import Seaborn. All right. So this is coming from my tidy data frame. And then I can easily just say, okay, the X variable is treatment, the Y value is result, right? So we got treatments here on my X axis, result on my Y axis. And then the column here, this generates different subplots of my graph based on name. So here's John Smith's plot, Jane Doe's plot, Mary Johnson's plot. I'm saying it specifically, I wanted a bar plot, and I don't want the height to be 2. There we go. Now it's big. All right. So this is called a categorical plot, cat plot. So what is this function doing? This function under the hood, it's calling matplotlib code to make this graphic. Right? If I wanted any customization beyond what's here, I would need to use matplotlib code, right? If I wanted like what should I call this? Treatment results. I don't know. That's a terrible title, right? Oh, it's a facet grid. All right. This is going to be a pain. We'll get more into this tomorrow. Moral of the story is if I wanted any customization beyond what's already here, I'd need to use matplotlib. So by learning matplotlib, you're kind of also going to learn some Seaborn at the same time, right? But both of the libraries are highly interrelated. All right. Now we're going to use Instacart data. All right. We're going to re-import from the CSVs these 3 data frames. And here's the graphic. We're not going to completely remake this graphic. We're just going to do one of the green lines and one of the red lines just for practice here. As a stretch goal on the assignment, you can try and remake the whole thing. All right. But we're just going to try and do half and half ultra pasteurized, which is the top item here, and half baked frozen yogurt. To be clear, these are not all dairy products, but a lot of them are. They're just trying to show that there are sets of products with Instacart that tend to be bought early in the morning, and there's other products that are more bought in the evening, kind of when they're consumed. And they're showing that the hour of day something ordered is important. So these are some of the most popular items that were bought during these times of day, but I'm not completely sure how they arrived at this subset. These are not the most popular items at Instacart. They're just some of the most. And they've kind of been cherry picked a little bit so that they're specifically showing extremes of things that are bought in the morning or in the evening. And it kind of makes sense. If you're buying half and half or coffee creamer or something like that, it's different than if you're buying kind of dessert ice cream, other things like that. You can imagine there's reasons for why these 2 graphs look like this. All right. But we want to recreate this pattern. And what we need to recreate this graphic is we need quantity of orders by hour of the day, right? Just like we needed treatment results by treatment, right? We need something in a similar format. But again, I'm going to need to do a little bit of subsetting and a little bit of merging here. I'm going to do that a little bit quickly here. First off, I only care about 2 products. I'm just going to do this for 2. I have to type this exactly right. Half-baked frozen yogurt and half, all caps, ultra pasteurized. Got title formatting here. Title casing. All right. Now, I'll look at the lists of our columns again. Right. This is so we don't have to print out the whole data frame. I can just easily see what the column headers are, which is what I most care about when I'm trying to see what's in a data frame. And here's the column headers of my orders. And I also want to look at order products, and you got to spell columns right. All right. Now I know, just a quick reminder of what my columns are. This is a little bit more concise than printing out, doing a whole dot head, and it doesn't take up as much space in my notebook. All right, but this next part I'm going to do is going to be a little bit complicated. Right, so we've done individual merges before. I'm going to chain merges together. Right, so I'm going to say merged. First, I'm going to merge products, but I only want these 2 columns. Oh, orders.columns.toList. Ryan says, I think that answers my question about what if there were hundreds of columns. Yeah, this is one way we could get a list of column headers, and then even if we had to do something with this, we could loop over this list and manipulate it somehow. All right, so I want to take the products column with products ID and product name, right? I'm filtering to get only those two columns. I want to merge that with order products. And from that, I only want two columns as well. I only want the columns order ID and product ID, right? If I didn't have my notes I was referring to right now, I'd have to do a bit of experimentation here. I couldn't just come up with this off the top of my head. It might seem like that because I'm referencing my notes, but that would not be the case. So I'm gonna merge that again with orders. And from orders, I only care about retaining the columns order ID and order hour of day. All right, so really, what do I want here? What I want is I want the product name and the hour of day it was ordered, right? But those two things live in two different data frames. And the data frames that they live in don't have any ID columns that are the same that I can merge on, right? So the orders column only has order ID, and the products data frame only has product ID. So there is no ID column I can use in those two data frames to merge these two together. Luckily, I have my join table. Order products has both of the IDs. So I can use that as kind of the intermediary, the middleman, to say, okay, pull the important things from products and pull the important things from orders. All right. And this might restart my runtime. I've only subsetted here based on columns. I haven't subsetted based on rows yet. This means this is going to be a pretty big merge. Let's see if it breaks my notebook. I hope it doesn't, because if it does, it'll set us back 3 minutes. So you can watch this RAM bar. Oh, it worked. Praise be. All right. What do I have now? I have product name and order hour of the day. Those are the two columns I really cared about from the beginning and for making this graphic, but there was no IDs in either of them that I could use to merge them directly. So I had to use this kind of intermediary merge to pull it all together. All right, that's why I'm using two merges here between three data frames instead of just one merge between two data frames. Hopefully you can see the need for this middle data frame. All right, but again, this is over my 80 character line, which does not follow PEP 8 code styling conventions. So I'm just going to new line these here so that it's not super long. All right. But at this point, I have the information I need in one single place. I now need to reshape this and plot it. Remember, so when I want to reshape, what do I want? I want one column that is the hour of the day something was ordered, and I want another column that represents the quantity of orders, right? Because I need one thing for my x-axis, I need one thing for my y-axis, but right now, these are individual orders, right? So I need to sum up all the different instances of chocolate sandwich cookies and all the different instances of sliced American cheese, et cetera, et cetera, et cetera. But only for the two products that I actually care about, right? So first off, let me filter this, and I'm going to say, I'm going to call this two products, and I want merged, but I only want merged where product. There's a better way to do this. I was going to show you one more way. Okay, here's what I was about to write out, and I'm going to copy and paste for time's sake, right? So this is the same kind of data frame filtering we've done before. We set up a condition. I either want product name to be half and half baked frozen yogurt or half and half ultra pasteurized. If it's either of those, retain it in the data frame after the filtering, right? This is very similar to what we've done before above. I want to take this opportunity to show you one more syntax, right? All that I need is something that evaluates to true or false if it sees either of these two product names. All right, that's the end goal with my filtering. So what I can actually do is, remember I have product names here. I'm going to copy it down just so it's something visible in the same cell. And I'm going to say that my condition here, and I'm going to use the is_in function. Right? So what it's going to do is it's going to look through all the different individual product names. If it's in this list, it evaluates to true. If it's not in this list, it evaluates to false. You notice that this is a little bit more readable, human readable, and it's not as long as what I've got going on here, which, by the way, is over the 180 character line. Excuse me, the 80 character line. So I'll do that. This reads closer to plain English, right? Which is typically a good thing, that readability. My condition is that if the product name is in product names, keep it, right? And now, notice that with both of these cells, I should get the same result. And why didn't it? All right, same thing. Data frame filtering, you just need things that evaluate to true and false for each item, for each row of the data frame. All right, at this point, I am going to actually split this into 2 data frames, all right, before I do my actual plotting, right? So I'm gonna call this first data frame froyo, and it's every time things are half and half baked frozen yogurt, and then I'm gonna call it cream every time it's half and half ultra pasteurized, right? So this is filtering, splitting it into 2 data frames. I mentioned yesterday when we split things into managers and plebeians, right, that would help us graph them independently and kind of compare and contrast. The same principle is going on here about why I'm putting these into 2 different data frames. All right, and now I want to take cream, order, hour of day, dot value counts. Remember, that's going to tabulate up all the different orders by hour of the day. Right? You see most popular around the morning time, less popular in the middle of the night, but these have raw value counts. So this is the number of orders for each of these hours. And that's not actually what my graphic here shows. It's not showing raw counts, it's showing a percentage here, right? Percent of products, of orders by product. So what I need to do is I need to take my value counts and I need to tell it to give me percentages. So I'll say normalize equals true. And notice these are all in the same order, but their percentages now instead of raw value counts. And then I'm also going to sort this by hour of the day, by the index. Now it's in order. Remember, the goal with tidy data format, get the values you need in a single column. This is not explicitly tidy data format, but it's achieving the same thing. It's getting the values I want in a single column. All right. Now, this is just kind of test code that we've written to show you how we arrive at this, but I'm explicitly going to now plot these, both of them. And I'm copying and pasting here. I, again, slightly apologize for that, but the code will be here, right? Same thing I'm doing above. Taking my data frame, value count up to get the percentages, sorting the value counts by hour of the day, and then plotting it. But for both of them, for both cream and froyo. All right. And you notice this is starting to look a little bit like my other plot, but just only with 2 of the lines. I also don't have X and Y axes labels. I don't have a title. This isn't the right colors. I don't have a legend, right? There's a lot of differences here, but the important thing is that these lines look the way they should. The data is correct, even though some of the other housekeeping aspects of this plot aren't completely there. We'll learn how to control those aspects of our plot tomorrow, right? So this is just proof of concept about data formatting, translating to the right plot shapes. All right, so now here we're going to use a crosstab. Remember, we've used crosstabs a little bit so far. We can also use crosstabs to manipulate the shape of our data, right? You've already learned quite a few data reshaping tools, whether you know it or not. So I'm going to use pd.crosstab. And then remember, I want to give it the categorical columns, the categorical values that I want it to tabulate things based on. So I want the hour of the day, and I also want the product name. Notice that I'm not doing this on the individual cream and froyo data frames. I'm doing it on just the subset that has both of them together. And I'm using letting the product name generate this for me. Let me just show you what this crosstab looks like once my notebook wakes up. Order hour of day. All right. The first thing that you pass to a crosstab becomes the row index, right? Hour of day, here's my row index. The second thing that you pass is the column index. All that a crosstab is a data frame with a specific row index and a specific column index. All right. But you notice this has the information I need, just like before, just like my value counts. But again, here it's in raw counts. It's not in percentages. Again, I need to say normalize. But instead of normalize equals true, I'm going to say normalize equals columns, right? So it's going to say calculate percentages based on the columns, not based on the rows. And here's now my percentages. And I can just call dot plot here on the end. Dot plot, its default functionality is to give me a line plot. So I don't need anything more than that with my dot plot. And now I've got a crosstab. Notice the crosstab automatically gave me a legend here because it knew what those legend values should be based on the column headers of the crosstab. But yet again, this is longer than my 80 character limit. I will reformat. Does the same thing. All right, now we're finally to the two things we're focusing on today, pivot table and melt. You're going to notice this is going to be very similar to above. My index, right? What's the unique identifier for each of the rows? What should it be? Well, it should be the order hour of day. What should my columns be? Where are the values that I really want? Well, those are in what defines them is the product name, right? So when I have one column name for one product and one column for another product, and then my values here are order ID. All right. And I actually need one other thing here, something we haven't talked about yet. It's called an aggregate function, or an agfunc for short. The problem here is that by default, pivot table is going to calculate the average. It's going to calculate the mean, and I don't want that. I want percentages. So I need to say that the agfunc here is length, and that's going to calculate percentages. We haven't talked about agfunc yet. You're not going to need to know it super well. Just know that I have to use it in this instance so that I get percentages. And there we go. And again, I'm going to clean this up. All right. And finally with melt, right? I'm going to say, why do I? All right. Oh, okay, I'm gonna copy in a little bit here, and then I'm gonna explain what's going on. First off, in order to melt something, I need it in wide format first. So here it is in wide format. Notice two different columns. This is my crosstab from before. I don't think I need this. Maybe I do. Anyway, here it is in wide format, so I can start working with it. But it's I'm putting it in wide format by the crosstab instead of by the pivot table. Don't let that confuse you. It's still wide format. All right, so I'm going to say, first off, I need hour of the day as a column here, just like I did before. So I need to reset the index. And as I do that, it's pulled hour of the day in, right? And then I want to actually melt it after I have reset the index. And I want the ID vars. What indicates a unique row? Well, it's order hour of day. And I think that's all I need. Let me show you what this looks like, but I need to, if I run this twice, it'll mess up. So I need to reset my table. All right. Tidy data format. One column is unique identifiers. One column, this is like my treatment column, treatment A, treatment B. And the values I care about, again, all in one single column. All right. If I want to be really picky, again, I can rename my column. I'm going to copy this. All right, so this is me doing all the same changes I did to the Hadley-Wickham table example, but instead of doing them in individual cells, I'm chaining the function calls together. I start with my individual table, I reset the index, I melt it, I rename the columns, right? All kind of in one nasty one-liner, but hopefully you understand the individual parts well enough to understand what's happening here. All right. And I'm just gonna say that to a variable. I'm gonna call that melted. Actually, I'm not. I'm just gonna say dot plot at the end. Unexpected end of file while parsing. I need a parens here. Now that is not right. Why is that so wrong? Let's look at the table itself. Okay, that looks right to me. Oh, I need to use a Seaborn plot here. All right, so I'm finally using Seaborn because I have it in tidy data format. I can't just call dot plot at the end of it. Dot plot uses a matplotlib plot. I'm going to use a specific Seaborn plot. This is what I renamed the columns to. I'm going to make sure that the color here is based on the product. And the data comes from my melted. Well, it doesn't yet. I have to save this to a variable. Come on, notebook. Come on, notebook. We're almost done. You can do it. Talk to my notebook like I talk to a pet. Anyway. All right, now it's actually in this variable melted. And I want to make sure this does a line plot. So tidy data format in conjunction with Seaborn. And there you go. Again, going to reformat the parameters here for some of these long lines of code. And here is a Seaborn plot. Notice it pulls the legend off to the side. It's a little bit skinnier, but the lines are the same. All right, so 4 different ways of being able to plot things. Notice the theme, or the thing that's common among all 4 of these methods, is getting the values we need in a single column. All right. Now that's not particularly the case with the crosstab. In the crosstab, it's in 2 different columns, but we used a plotting functionality that pulls that information from two different columns, right? Actually, we'll get rid of the funny output at the top. All right, so for today, you're focusing on 3 and 4, but you've already used value counts and crosstab. Just wanted to show you that they are important data reshaping tools as well. What's the opposite of is in? And then Joseph shows the tilde. That is correct. So if we use tilde somewhere, I don't know if we put it at the beginning. Tilde is called the unary operator. What it means is it negates things. So it's going to take trues and turn them to falses, and falses and turn them to trues. Anyway, so that is the opposite. I mean, you can even Google opposite of is in. Logical not. They're using NumPy here, or the tilde. Right. Or you can do data frame and say is in and make sure that that equals false. Anyway, lots of ways to do it. Lots of ways to toggle trues and falses back and forth, or to flip the Booleans there. All right, that is the end of lecture. I won't keep you any longer so that you can go and jump in with the brown bag if you want. I'm going to do a quick write-up in Slack talking about your assignment this afternoon. We're going to use the same data set, but we're going to do a few different things with it. Make sure that you subset before you merge. You'll probably get instances that'll crash your collab if you don't do that. So just be extra careful about that, and I will let you jump into the brown bag. Thanks, everybody. Thanks for your participation and your attention, and I hope you feel like you're getting better with pandas and getting really good chops here with these skills. So thanks, everybody, and I will see you after lunch.